So the idea of this workshop is to present you and to learn you step by step how to master the double emulsion production. For that, I will first introduce myself briefly and introduce the team as well. My name is Meziane. I'm working as project manager at Fluigent for droplets and particle application. And on the other side, we have 𝗪𝗖𝗔 and Adrien Dewandre from 𝗪𝗀𝗥𝗞𝗦𝗪𝗛𝗏 and they are both technology lead encapsulation, and they have strong expertise in encapsulation of active ingredients inside single and double emulsion. The purpose of this workshop today. So I think it's now the time to start. So Adrien and 𝗪𝗖𝗔, I give you the lead.
Okay, welcome everybody. Thank you, Adam, for this introduction. My name is Adrien Dewandre from 𝗪𝗀𝗥𝗞𝗦𝗪𝗛. I'm going to give you a very short introduction to the generation of double emulsion using the device called Raydrop that we have developed at Sequoia. And just after this 5 minutes presentation, we will focus on the live demo. The Raydrop device is made of a metallic chamber filled with the continuous phase in which two inserts supporting glass capillaries are introduced on the lateral sides in such a way that the capillaries are almost in contact at the center of the chamber. A nozzle printed with a sub-micrometric resolution is fixed onto the tip of the injection glass capillaries. The input capillaries provide the core and the shell fluids in the nozzle, while the output capillary collects droplets. At the entrance of the output capillary, the continuous phase pressurized in the chamber is subject to a dramatic acceleration because of the change of section and squeezes the droplet phases flowing out of the nozzle, resulting in the formation of double emulsion droplets. The system presents practical benefits, actually. A producible fabrication technique because of the use of a 3D printed nozzle and alignment of the parts in the chamber based only on mechanical tolerances. A good observation condition through the two glass windows closing the chamber, a connection to the fluid reservoirs using standard fittings, the possibility to fully disassemble the device for cleaning, and finally, the possibility to change one insert if you want to change the nozzle or extraction capillary or both to modify the droplets size range achievable. The Raydrop is easy to set up, as you can see on the scheme. 3 lines of a pressure controller are connected to 3 reservoirs. Each reservoir is then connected to a filter to avoid contamination of the device in series with a flow meter to measure the flow rates. The continuous phase is directly connected to the chamber, while the core and shell phases are connected to valves. The valves allow to control the sequence of introduction of the core and shell phase. This setup is fully implemented in the emulsification platform that you see on the picture and that you will see working in the following live demo. It makes the system easily and immediately ready for double emulsion production. At the output of the device, you can choose to collect double emulsion or to connect the system to a chip to perform sorting, analysis, or other operation. Okay, now what kind of double emulsion can we produce using the Raydrop? Actually, water in oil in water or oil in water in oil using the same device, because there is no coating needed, with adjustable shell thickness by adjusting the flow rates. We also demonstrate the production of microcapsule by polymerization of a shell in the tubing connected to the output of the Raydrop. The result is monodispersed capsules with a solid shell and an aqueous or oil core in which it is possible to encapsulate molecules. PLGA, alginate, chitosan, and many of the shells of interest are, of course, made possible using the device. Okay, now I'm going to let the floor to my colleague 𝗪𝗖𝗔 for the live demo. Thank you for your attention.
All right. Here you have a view of the platform emulsification platform, but I will start with the Raydrop that you can see here. So you have the size. You can see the chamber, inlet and purge here and here for the continuous phase. And here you will have the entrance for the shell phase and for the core phase. And on this side, you will have the exit for the collection. On the emulsification platform, you can see So 3 pressure controller connected to 3 reservoirs. You have 3 inline filter to avoid any clogging of the system. You will have 3 flow meter on this side. And then you will have here 3 valves to start the process. Everything is connected to the Raydrop that you can see here. And you will have then a camera and a light for the observation of the experimentation. And on the side, we have a binocular just to see the double emulsion. So to start the experiment, we first go with the continuous phase. We can set, the pressure will vary depending on the tubing that you use and the fluid also that you use. But we start with the continuous phase. Then we add pressure on the shell phase. So here the shell phase is mineral oil with span 80, and for the continuous phase it is water with twin 20 at 2%. Then I switch the valve here to start the flow rate inside the chamber, and you can see some oil moving. So I will increase the flow rate of the shell phase to flush the remaining water and oil that was in the nozzle. All right. So now it's clean. You have oil all around the chamber, so we can decrease the flow rate of the shell phase. And we can start to add pressure. A bit less, a little better. And then we can switch the valve for the core phase to generate double emulsion. And in the core, we have water with fluorescein to help to see the double emulsion formation. So what you see here is that the shell phase is not strong. The flow rate of the shell phase is not strong enough, I would say. And so it will break the double emulsion formation, but it's not a problem because you just have to adjust both flow rate of the shell phase and the core phase to have the desired double emulsion. And to help also start again the process of the generation, you will have to stop the core phase here with the valves and then start again, and it will start again. And so now we can collect. We just have to wait a few minutes still so that the double emulsion go through the wall tubing of the outlet, and then we'll be able to watch them under the binocular. And if you have a question or you want to see something again, we can do it again.
Okay, so thank you everyone for your attention. And if you want to have more information, feel free to contact Fluigent. We can organize separate discussion on your application, on what you would like to know a bit more about our project. And we keep in touch then. So thank you everyone.
Thank you very much.